I'm Gabriel, and today I'm going to be talking to you guys about building cross-platform desktop apps in Electron.js. So before we do that, I just want to talk to you guys a little bit about myself. I'm the Chief Electron Officer at 01. There's a few things that you need to know about me. The first thing is that I am a JavaScript expert. What's that? The second thing you guys need to understand about me is that you can implicitly trust absolutely everything I tell you. What? Okay, the other thing is that I am also an Electron guru. And the other thing is that I also work for this company. I work for a small but really, really awesome development company called 01. Okay. That wasn't funny. All right, guys. Cool. So let's dive in. So what exactly is Electron? What is this Electron thing? So there's a few things that you need to understand about Electron. And the first thing is that Electron is a framework that is built on three core technologies. The first one is obviously JavaScript. The second one is HTML. And then the third one is CSS. So you can write cross-platform desktop applications using the technologies that we use every single day. The other thing is that Electron is built on these three core components that are wrapped around the Electron framework. So the first one is Chromium. And with Chromium built into Electron, you get Chromium's amazing rendering engine, you get its GPU acceleration, you get HTML5 compliance out of the box. Over and above that, the V8 engine is brought in, and with that you get V8's speed, and you also get the ES6 compliance with V8. And you don't need to use any transpilers like Babel or whatever to get that kind of compliance. It's just native ES6. And then finally, it's built upon Node as well. And that brings in all of Node's amazing APIs and all of the NPM ecosystem. So Electron is this framework that's built around these three core components using technologies that we use every single day, and all of these together allow you to build cross-platform desktop applications. Okay, one other thing to understand is that these versions are all stable within an Electron release, and because of that, you don't have to worry about thinking, does Chrome support this? Am I going to get this version, this API and this version of Node, that kind of thing. You can count on specific versions of these components built into Electron off the bat. And to give you an idea of what is possible today in Electron, this is a tiny, tiny, tiny percentage of the applications that are built in Electron today. And I'm sure there's going to be at least some of these applications that you recognize. I know I use personally about a handful of them. Okay, so that's what Electron is. But the other thing is that this is 2016, so why would we want to build a desktop application in 2016? The web has come so far, it seems weird, right? But it turns out that there's actually a few reasons why you still want to build desktop applications in 2016. And here's a couple of the reasons. The first is perhaps your application requirement has a need to run in the background. And you don't want to rely on your browser being up because your browser might crash. And if your browser crashes, that background app dies. The other thing is you might require file system access. The things that make browsers so powerful with web applications and so usable, and the reason that they've taken off so much is because of the security model in browsers. You're downloading arbitrary code from the internet and you're executing it on your machine. Browsers have to be extremely sandboxed in order for people to trust them. And as a result of that, things like file system access are things that you are completely locked out of. You cannot access the file system unless you're doing some leet hacking like Patrick to win an Amazon Echo. You can't do that kind of stuff in a browser. Perhaps your application requirements also require you to make direct API access to something. So if you're downloading a web application, you can't tell that web application, okay, guy, now initiate a connection from my browser to some API over there. You can't do that. So if you need to make that kind of connection, you have to do it from your local machine, and you have to initiate the connection from your machine. And that's why we see things like API clients like Postman. We download an API, we download the Postman app, and we tell Postman to make those connections out for us. You can't do that in a web application. And then the other thing is, perhaps your application requires you to make connections to hardware, local hardware on your machine. So for instance, like you got a Bluetooth card, or you want to play with Sphero, or you have, you've got like a smart card reader. That kind of stuff you can't do from within a browser. You need access to local APIs that can speak to your local hardware so that you can make those connections. But why else would you want to write an application in a desktop today? Well, perhaps you have a requirement for on-premise access. So it might not make sense for you to install a web application with a web server and then everyone connects to the web server. That might not make a lot of sense. So instead, you want to just connect locally using a desktop application and bypass all your corporate firewalls. The other reason is you might require binary protocol access. So if you need to make a connection to a Postgres database, you need to make a connection to MySQL, that kind of stuff, it's no bueno on a browser. You need to make that connection using Postgres drivers that are compiled down to C that you can use as a client library. Okay? And then the other thing is, like, some applications just feel right on a desktop. You know, from my side, I'm not really a big fan of Gmail. I can't use the web interface. I'm like a dyed-in-the-wool. I need to use like a local mail client. Some applications just feel right. That's why we all have Slack installed on our machines today, instead of using the web application. You see what I'm saying? You guys understand? And then the other thing is like games. The desktop is still the predominant place to download games and run them. So that's why I think there's still a place for desktop applications today in the year 2016. But why would you want to build a desktop application in Electron? And there's some reasons for that too. So one of the things that Electron gives you is you only need to learn one framework. And what I mean by that is you just need to learn Electron's API. It's relatively small. And then you can reuse all your JS, your HTML, and your CSS skills that you've been using for all these years. If you're on a Mac, you don't need to learn Cocoa. You don't need to learn the Windows APIs if you're on Windows or whatever Linux is using these days for the desktop. You don't need to worry about any of that. Just use Electron, write it once, and you can use it everywhere. The other thing is Electron gives you some really amazing tight OS integration. So you can do stuff like activate notifications. You have access to the task switcher. You have access to menus. You have access to global shortcuts. You have access to system-level events. So you can detect when your computer's gone to sleep. When your computer wakes up, you can understand when your CPU is going nuts and do something about it. You have access to all of these system-level events which allow you to write really interesting applications that are really empathetic to what's going on with the user's machine at that time. And then finally, you get a lot of code reuse with Electron. If your application is a companion to a web application, there's a really good chance that you can take some of those assets that you've been using on the front end and with a little bit of work, transport them over to your Electron application. But as a bonus, like if your backend is running Node, there's also a really, really good chance that you could take some of that backend code that's running Node and transplant it into your Electron application. So this starts becoming a really, really compelling reason to write desktop applications in Electron, especially when you need that desktop companion app. You can actually save a lot of time because you've already done most of the work if you have that companion web application. But there's actually more. So the other thing is, when you write an application in Electron, there's actually an entire class of problems that traditional web developers don't actually really have to think about anymore. What I mean by that is, if you're writing to a local database on your local file system, okay, you don't have to make a network round trip there and then to ship all the data that you fetch from that round trip back. So you can start doing crazy things like expecting zero latency when fetching thousands of records and serializing them into objects. And that allows people who are writing stuff in Electron to start being a little bit more ambitious about what they're trying to deliver in an application. And then the other thing is, you get Chrome DevTools for free when you are trying to debug an Electron application. And the reason for that is because Electron's, one of Electron's core components is the Chromium engine. So your application windows are actually Chromium windows. What that means then is that you can summon DevTools, not in like a separate Chrome browser, but from within your actual application, and you can debug your application live using Chrome DevTools. And we all know like Chrome DevTools is pretty much the state of the art when it comes to debug tools for developers. And then this one's pretty important to me. I think the desktop is a new frontier for developers, especially developers like us. We have traditionally been locked out of this entire part of the development culture. We now have the tools to take our skills that we've learned over all these years and bring them to a completely new place where we've never used them before. And for me, that kind of growth in a developer doesn't come around too often. You know, we had a growth explosion like that with mobile, and this is something that we can now move on to and start really being amazing at as well. And I think that's why there's still a reason for desktop applications today, and there's still a reason for those applications to be written in Electron. That's cool. How exactly would you go about making an Electron application? So, spoiler alert, it's actually really, really simple, and I'm going to walk you through the bare bones now. So the first thing you've got to do is you've got to initialize your application. So npm init, and then what you want to do is you want to pull down Electron pre-built. Some saint somewhere on the internet has compiled all the different permutations of Electron and packaged them together so you don't have to. It is a nightmare to compile all those things together. Don't do it. Avoid it. Just do that. You will save yourself a lot of time and heartache. Once you've done that, you want to configure your application. And this is what your package.json looks like. You give it a name, a product name, version, whatever. The one that's really important is this one, main. You are specifying an entry point into your application. So when you do electron dot, or you say npm start, it's going to look for that main key. It's going to then try and grab the JS file that's specified in main, and it's going to attempt to run your application from there. So once that application, once that's happened, your application needs to start up, and that's what this looks like. And I'm going to walk you through this as well. So don't freak out. It's actually really, really simple. The first thing you got to do is you pull down the Electron object by requiring it, and then you do some really nice ES6 destructuring. And again, there's no babble in my package.json. This all happens natively. So you then pull down the app object. The app object manages your application lifecycle. And you pull down a browser window object from the Electron object. And the browser window is a module that will spawn windows for you. It does a whole bunch of other stuff, which we can get into in a bit. The next thing that I do is I declare a win variable. And the reason I do that there, and I just say let win, is because I want to declare it as high up in the scope as possible. And the reason that I want to do that is so that it doesn't get garbage collected. Because if it gets garbage collected, all my windows disappear. So we put it all the way up there. After that, I create a function called createWindow. I don't create it as an inline callback. I create it separately, as you'll see later. And this is also very, very simple. All we're doing is we're creating a window object. I'm giving it some options. In this case, I'm saying make an 800 by 600 window. And you can actually do a whole bunch of things. You can tell it, like, make it resizable or not, or give it a border, an operating system frame, or make it frameless. You have these options to do that. And then from there, I load a URL. This can actually be anything you want. It could be something on the network, or it can be a local file. In this case, you're probably going to want to run a local file. And you can see over there, I'm using some nice ES6 template strings. Again, very cool. Don't have to do anything in terms of Babel again. And then I'm pulling open DevTools. So you can programmatically open DevTools. I recommend you keep that going while you're doing development, and then put a sticky note somewhere to switch it off before you go to production. And then what we do is we just say, when the window closes, listen for the closed event, null the win variable, and your window closes. What we do is, once Electron has bootstrapped everything, it fires the ready event, and then we just call create window. So as soon as Electron's ready, it spins up your very, very first window. And then we do some stuff which works around the differences that macOS has compared to Windows. We say over here, if your platform is not Darwin and all the windows are closed, then you can quit the app, because that's how Windows apps work. You close all the apps, the app quits. On Windows, on macOS 10, when you close all your windows, the app stays running, and you have to Apple Q to quit it. So we do that there. And then we say when the app is activated, which means when you click on the icon, If there are no windows, create a window. Very, very simple. So that's how you bootstrap the application. From there, you're probably going to want to pick an app framework to help you out. So you have a number of options. The first is you could use React and Redux if you wanted. Sorry, Simon. It's not personal. It kind of is personal. If you don't want to use React and Redux, you could use Angular. Angular requires a little bit of tweaking to work properly in Electron, but that's fine. There's lots of documentation on the net for that. Or you could use Ember. Ember has fantastic, fantastic support for Electron. And you can control a lot of the ways that Ember interacts with Electron through an Ember CLI add-on. Or you could use anything, really. And if you don't want to use anything, you could use nothing. The point is that it's all just JavaScript, okay? If you don't want to use it, you don't have to use it. You can use all the other parts of the JavaScript API natively if you wanted. Okay. So once you started building your application, okay, you've now picked an app framework, you understand how things work a little bit in Electron's main process. What you want to do from there is you're going to start thinking about the user interface, right? This thing needs to look like something. So you have a number of options here again. I think you're going to notice a theme. The first is you can pull down PhotonKit. PhotonKit's really awesome. It's an HTML and CSS library that will give your application a very native Mac feel. But it's Mac only. They're going to be doing Windows support later. And these things are effectively like the style guides or the component libraries that Garen and Ben were talking about in the previous talk. If you don't want to use Photon, you could use Bootstrap. Bootstrap is, I mean, everyone uses it, and you can use it if you want. I know a lot of people use Bootstrap as their very first attempt when they're building something in Electron. And if you don't want to use that, I suppose you could also use React Desktop. React Desktop is pretty cool if you're using React as your framework because it also allows you to switch between a Windows look and feel and a Mac OS X look and feel. So that allows you to get that nice cross-platform user interface going quite easily. And if you don't want to use those, again, you guys could use really whatever you want. At the end of the day, it's still HTML and it's still CSS. And you need to know, and all you need to know is if it looks good on Chrome, it's going to look good in Electron. Okay. And what does an index.html file look like? Well, it looks something like this. But there's some interesting stuff that's happening here. As you can see, standard HTML5, but check this out. We're doing a document.write, but we're calling process.versions.node and process.versions.chrome. We actually have access to a lot more than just the standard browser JavaScript in the context of Electron's browser window objects. We can call pretty much anything. You could call a node module from here if you wanted, a node module that's specifically meant to be used on the server side. You can do that from here. Okay, so now you've got your application going, you've picked your application framework, you've got your user interface, and you've maybe got a couple of windows going. The way that Electron works is these Chromium windows might need to communicate back to the main process, and it does that via IPC, or inter-process communications. The way that works is you set up a whole bunch of listeners, and you start firing off messages back and forth to one another. Let me walk you through how that works. So as you can see over here, we've got the main process, and at the bottom we've got a block of code that would run in a renderer process. The renderer processes, once again, are the Chromium windows. Okay, so let's see. You have two options when you want to start sending these messages backward and forward. The first that you can do is you can send your messages synchronously. Probably not a good idea. You probably do not want to do that. And if you do that, you better have a really, really good reason because it's going to affect the user experience of your application. Or you can send your messages asynchronously. And this is how that works. So let's send a synchronous message first. So you can see over there, we send a synchronous message from the IPC renderer object to a channel on the main process that's listening for synchronous messages, and it's called synchronous message. We send it an argument called ping, and then it comes in there, and we'll print out ping. And then we return a value over there, and we'll print out pong on the renderer side. So that's how these two processes can communicate, and that's a synchronous transaction. But we can also do this asynchronously. So if you look over there, the third line in the renderer object, the renderer code block, we'll send a message to the asynchronous message channel in the main block, and you can see we're looking for asynchronous messages over there. And we will send it a ping again. That ping comes through, and we print it out. And then what we do is we take that event object, and we send it back asynchronously to the renderer process. And you'll see that there we send an asynchronous reply with pong, and it goes all the way back, and then we print out pong. Really, really simple. And there's some very interesting implications about what this means for us building Electron applications, which we'll get to in a minute. So we've bootstrapped the app, we've picked an app framework, we've done the user interface, we've done a bit of IPC. The application's probably more or less done right now. Now's the time that you want to start thinking about packaging your application. And again, you have a number of options, but really I'm going to save you a lot of time. Just use Electron Packager. What Electron Packager does is it can take all the different operating systems and all the different permutations of the architecture on those operating systems and package them up for you. So you can have around 6, 2 for Windows, 2 for Mac, 2 for Linux, and you can package them. You can see in the top example, I'm packaging my application for Mac OS X on 64-bit architecture, and I'm just saying overwrite any previous versions. That's if I want to make a specific build for a specific operating system and architecture. Or I could just say, you know what, like make it for everything. Let me go back. But now once you've got this packaged app, you need to then like distribute it, right? So what I would recommend you do is check out Grunt Electron Installer for Windows. You point that at an Electron application and it will generate an installer for you so that someone can click next, next, next. Or you use Grunt App DMG for Mac OS, and that will generate a DMG file for you. It'll give you some nice icons. It'll do that whole like drag to applications thing that you find in all Mac OS applications. There's a separate thing over here which I haven't shown you because it's like a lot of command line switches, but you can also package your application for the App Store on Mac OS. And that will then take your developer key. You sign your application with your developer key, and then you can upload it. And you can actually take your applications and you can put them on the Mac App Store and make some money. Pretty cool. Okay, that's all good and well, right? But you guys probably want to think about some things when you're building your applications that you can leverage as much of the power of the Electron ecosystem as possible. And I've got a couple of them to give to you. So the first thing that you need to think about is that Electron is actually just like the web. Okay? What do I mean by that? Well, traditional browser techniques work, which means you can actually write a responsive desktop application. You follow me? This is something where a lot of desktop applications don't do so well in, you know? You shrink your application and then you got to like fiddle with 100 different like resize bars. We have solved that problem in browser land. And we can take that solved problem to the desktop for our users. That's amazing. The other thing that might be useful to think about when building Electron applications is that it's actually more than just the web. What do I mean by that? Well, the thing is, you have access to the entire NPM ecosystem at your fingertips now. I'm sure everyone's seen some kind of node module that would only work on like server-side node and thought, I'd really dig to pull that into my application, but I can't because that doesn't run in a browser. That is no longer a problem. You could write a front-end application for Cylon.js. You can't run Cylon in a browser, but now you can. Take Cylon, put it into an Electron app, and now you've got a graphical user interface for controlling your Sphero robots. And then finally, and just forgive me if I don't say this right, it's a really complicated word, but with Electron, you get ghetto parallelism. And what do I mean by that? Well, the thing to think about is everyone knows JavaScript is single-threaded, right? Single thread, single process. Except it isn't. Because Chromium, which is the engine that powers the Chrome browser, is a multi-process based application. So I hope the gears are starting to turn for you guys as I'm getting onto this. But check this out, right? You can take the multi-process architecture of Chromium, and you can start spinning up background threads to do heavy data processing in your Electron application. You don't have to render a window. Just say render is false or whatever the option is. I can't remember it right now. But you've now got an entire Chrome process that can be doing some hardcore data crunching, and it doesn't lock up your main thread and your main user interface. That's pretty cool. And then you can do all that number crunching, and you can stream the data back using IPC back to the main process, and then do something interesting with it. Pretty cool, right? The people that nod might get a prize. Okay. And that's awesome, but there's also some stuff that you need to be careful of, right? So, what do I mean by that? Well, the first thing is your code isn't protected. And what do I mean by that? When you package your Electron application, it takes the JavaScript, compiles it down, and then it packages it up, and then it puts it into an application package that you can distribute to a user. But anyone with a bit of time in their hands can take that application, crack it open, peer inside, and get access to your code base. There's some stuff that you can use. You can use ASAR. It's an archive package for Electron. ASAR stands for Atom Shell Archiver. Or you can use Uglify, but that's really still only going to slow people down. That's not going to completely lock them out of your code base. There are some commercial options. I believe Slack uses something. So it's just something that you need to think about. Like if you're not cool with your code being out there, your business logic, you probably don't want to do this. What else? If you learn Electron the way I learned Electron, it was by scouring the internet for tutorials. But Electron's now post 1.0, and almost all the tutorials I read were at 0.3 whatever. The API for Electron has undergone significant churn. So be very careful when you're learning Electron to always keep the official Electron API guide docs handy, because when you're running your app and it throws an error and you don't know what it is about, it's probably because of that. So you can go and take your old API and you can port it to the new Electron API. The other thing you've got to think about is you're actually firing up a Chromium instance here. And Chromium can be a memory hog, just like its packaged browser, Chrome. Every time you fire up a renderer process, if it's to do background processing or if it's to render an actual window, you are consuming resources on a user's machine. We've kind of made peace with the fact that browsers can reach 1.5 gigs of RAM if you wanted, easily without breaking a sweat. I know my Firefox goes bananas after it's been open for half an hour. But not a lot of users are okay with too many applications acting like that on their local machines. I kind of make an exception for my browser and I make an exception for my IDE. But other than that, like everything else kind of needs to be a good citizen on my desktop. And your users are going to expect the same things of you. Make sure your application respects the resources that it's going to be using on the desktop. And then finally, you're doing like a tiny app that does like one little thing. You're making a Pomodoro timer. You're making something that, like, I don't know, checks a stock counter. It does one tiny thing. You're looking like 50 meg payload off the bat. And that's because you're packaging Node, you're packaging the V8 engine, you're packaging Chromium, and you're packaging the Electron framework all into that. And like the minimum ticket to ride is 50 megs, thereabouts. So that's not too much of a problem for running that application on your machine. I mean, everyone's got like gigs of hard drive space free, but there are some implications around application distribution. If you've got an S3 bucket that you're using to push your application down, you're going to want to think about what the cost implications are for that. All right. So where do we go from here? So the first thing I would recommend you guys do is check out the Electron guides and their official tutorials. The documentation is written fantastically. They've put a lot of care and a lot of thought into how they put how they've put this documentation together. You can learn a lot from that. I recommend if you're going to start an Electron, Start there. But don't stop there. No. What you need to do next is you need to mosey on over to Awesome Electron. So this is a GitHub repo maintained by that guy. This guy curates a list of everything that's amazing in the Electron world, from applications written in Electron to libraries you can use within Electron, all that kind of stuff. It's there. It's pretty much a one-stop shop. And then this is a bit of a weird one, but I think you'll agree with me, it's quite important. You guys should check out the Apple Human Interface Guidelines. If you're writing something for your desktop, this problem has been solved years and years and years ago. And that problem has been solved and then refined and solved again. Apple is pretty much at the forefront of building usable desktop applications. We've kind of had a bit of poetic license when we build web apps. We can kind of, do whatever we want. We make sure that they're still usable, but I mean, there's no real guidelines. If you want to do something completely crazy and off the wall and it works, it's cool. But on the desktop, users expect something different, right? And it's important to understand what those users expect. And when they expect it, you need to be there and you need to serve them what they expect. And the Apple Human Interface Guidelines are going to sort that out for you. You can take that knowledge, you can use it in Windows land as well, it's going to work just as well. And then finally, pair with me, man. I go to Code and Coffee quite often. Hit me up on meetup.com, codecoffeejhb, and let's just meet up and hack on an Electron app together. I've got a couple that I'm playing with now, a little sound machine. You'll push buttons and sounds come out. I think it would be really cool to make something. The next thing I want to do is make a Pomodoro timer that interfaces with my time tracking tool. So I can start a Pomodoro and it starts my time tracking tool and it stops it when it stops. I'd love to make that, and I would love to make that with somebody. So if any of you guys are keen, it's over there. Hit me up and we can do it together. Cool. Thank you very much, guys. Before we get into questions, I just want to say thanks to three people. Firstly, thank you, audience, for not throwing any rotten fruit at me. Thanks to Simon over there for not calling security when I spoke about React, and for organizing JSinSA. Let's give him a round of applause. And thanks to my wife, Anthea, who sat through hours and hours and hours of me rehearsing this. Thank you. All right, guys, if you want a copy of these slides, follow WeAre01. We'll be posting a link to there in a couple of days once we've made them presentation friendly. I'm happy to take questions. Nelson, and then you.
Not so much a question, just something extra, another gotcha that I found with Electron. Any NPM modules that have C binary or binary dependencies. So it'll work great while you're deving. So you download, you decide SQLite, it's a great database to use, but you're compiling against Mac or Windows or whatever your local dev is, and now you've got to have packaged for SQLite on Windows, on Linux, and on Mac. So just remember those type of things if you're doing anything with binary dependencies.
Cool. So I don't know if the mic picked that up, but Nelson just said if you're using natively compiled C binaries, you want to make sure that you can support them on different operating systems as well, and it's going to give you some unexpected errors later. Dude over there. Yeah.
So in the client server thing of developing for the web, client grown used to updates and that's rolled out almost instantly. Has there been much discussion about this with Electron Desktop?
There actually is, and I'm glad you brought that up because I didn't speak about it specifically in my slides. So the question was, when we write web applications, we push a change, we hit the deploy button, and then all of a sudden everyone's got the new version. What do we do with these desktop applications? Electron actually has built-in auto-update support. So it uses this thing called Squirrel. On Mac, it works really, really well. You can do silent auto-updates. And I know Windows is not quite there yet. They're doing some stuff with NuGet, where you publish your application to NuGet, and it can do updates from there. I haven't played around with it too much, but it is something that's actually quite crucial. Muzi. And then, yeah.
So I've played around with Node WebKit, and it does the same thing. What's the difference? What should I?
No, that's cool. Really, really good question as well. So Muzi wanted to know what's the difference between Node WebKit and Electron. Okay, so Node WebKit is a lot more low level. Its entry point is an HTML file instead of that main.js. And funny enough, the core contributor to NWJS is the main developer on Electron. I think he's actually moved off NWJS onto Electron. Yeah, they're pretty much all the same. NWJS is a bit more low level.
I just wanted to ask, you mentioned that it's a memory hog, which makes sense because it has to ship this whole environment that it runs on. Is there any way to constrain its memory usage?
I think again, this is where we've actually got quite a bit of an edge on normal desktop developers. Sorry, JW, right?
Yes.
Yeah. So JW's question was, how do you look after these memory hog situations? Like it's pretty simple. Chrome DevTools. Chrome DevTools has lots and lots of profiling tools in there. Profile your application, see what's going on, and optimize from there. You want a JetBrains? Okay, come get it afterward. All right, I'll take one more question, and I've got a JavaScript book to give away. Dude over there.
As we heard from our Koyo friends, Mahatma Gandhi said you should let other people judge you. Do you perhaps have an Electron app so you can show us?
I do.
Can you please show us?
Yeah, it's one I was working on from a tutorial. It's not quite finished, but I've got to say, dude, for putting me on the spot, I'm not sure I should give you this anymore. Okay. Okay, I'm just mirroring my screen. Projects. Okay, you guys want to see the code? I'm not going to walk you through too much of it. It's. Huh? Yeah, this is. Oh, by the way, guys, this is an Electron app. Okay, leave it. Let me just show you the app. It's a sound machine. Let me just get Chrome DevTools out the way. And then you can. Cool. I'm kidding. That worked out well, so you do get the book after all. Otherwise, we would have. Okay, wait. One more question. Anyone? There was a guy over there. Are you cool? All right, guys. Thank you very much. Oh, Kenneth.
You said there's a risk that somebody can crack open your code and have a look.
Yeah.
I mean, unless you've got logic in there that would otherwise be written on the server, that's exactly the same case for every website ever.
Yeah, that's true.
So it's not.
Yeah. So Kenneth's comment was, if they crack open your application, they're going to get stuff that was on like a browser anyway. Except this Electron also performs the function of a back-end application as well. There's some business logic happening there too, because it's not necessarily making a remote call. But that being said, like, I mean, us as web developers, once again, we've kind of gotten okay with the notion of showing our code. I think the only people that are really going to have a problem with that are probably the more corporate types that have some stricter rules around that and policies. But there are still some solutions that are just really, really clunky and painful to use. But if you really want it, you're probably going to like go the extra mile to do it. Okay, one more question, and then if you guys want to carry on talking with me, I'll be hanging out outside, and we can like go completely nuts about Electron. Yes. Cool. There's one more question over there. This guy.
So, if you want to get access to, so for example, the plugin doesn't exist to access your webcam, and now you want your application. I don't know if you covered it, but you write platform-specific code then for each platform, and is there like a plugin repository somewhere where you can get those from, or do you just rely on whatever's in NPM?
So I mean, like if you've got the ability to write like a native device driver, then you're probably not going to be writing Electron applications.
No, but what I compare it to is, for example, Apache Cordova for your phone. So you interface with the native device from within JavaScript.
Yeah.
So if you don't have support on iOS, you write a plugin. So it's a tiny bit of code that you write.
Yeah.
So that's why it's not the whole application.
So I don't know if there's native like webcam support for Electron, but the thing is Electron is architecture aware and OS aware. So you could conceivably have like a code path that activates webcam functionality specific for Windows, webcam functionality specific for OS 10. I don't know if that's quite answered your question. But we can talk about it outside. Tim.
You can, the same way you can compile node modules, you can compile node modules for that.
Your architecture.
Your architecture. The big problem there is you got to now if you want for Windows, Linux, whichever one you want a thing that you can write in C.
Yeah.
So you got that full capability.
Cool. All right, guys. There's popcorn waiting for you guys, and I'm holding you back. So let's go do that. If you guys want to talk to me, I'm outside.